So we're going to be continuing with simplifying radicals. The two properties that you need to know for this section are these two. That says if you have a square root of a product, that you can split up the square root. If you have a square root of a quotient, you can split up the square root. So this whole section is going to hinge on those two properties. So your steps, and these are for simplifying radicals that have multiple things inside the radical. So things that have like 36x squared. These are going to be your steps for. So you're going to break it up using either of those properties or both. Simplify each part. Now simplify means in terms of the numbers, you are not putting it in your calculator and rounding a decimal. You're giving exact answers, so you're simplifying like we're going to do in example 1. And then rewrite if needed, meaning move all of the numbers that are outside the radical to the front and put all the numbers inside the radical, put them under one house at the end. So our first example is just simplifying radicals. So there's only one thing under the house, 96, so there's nothing to split up. So the way you do these is you're going to take the number and do what's called a prime factor tree. That just means you're going to find the prime factorization of, in this case, 96. So the way you do it is you just find any two numbers that multiply to 96. So 6 and 16. Now you can do anything. You could do 2 and 48, 6 and 16, any two numbers that multiply. It doesn't matter. It's going to get us all to the same place. So keep breaking it up. So 6 goes to 3 and 2, 16, I can do to 4 and 4, 2, 2, 2, 2. So I know I'm done when down here on the ends I have only prime numbers, meaning they can't break up anymore. So because this is a square root, the index on the square root tells me that I'm looking for groups of 2 because it's the square root. So I'm looking for things that can be paired up. So I have 2 groups of 2 and then a 3 and a 2 left over. So what comes out the house is one number from each pair. So I have 1, 2 coming out from this pair and 1, 2 coming out from that pair. Now I've got those things outside the radical. The things that are left inside are the numbers that don't have any pairs. So I have 1, 3 and 1, 2 left behind. Now notice, because I had 2 things come out and 2 things stay inside, I put this multiplication symbol in between them. So my final answer is going to be 4 on the square root of 6. Now the way I would check that is I'm going to type in the square root of 96 into my calculator, and it tells me that it is 9.7979, and I want to make sure that 4 times the square root of 6 is the same thing, and indeed it is 9.79. Actually, should have rounded up to 80, but my decimals are right. So that means I know that this is the same thing as the square root of 96. So how you check that is with the decimals in the calculator. And the decimals are just to check. You can't actually, I don't want decimals in this section. Okay, so the next one, the only difference now is I'm doing the cubed root instead of the square root. So I'm still going to do the prime factor tree. So I still need to find 2 numbers that will multiply to 24. Now, yes, it's negative, so that just means my answer is going to have a negative out front. Now, technically, you could put negative 24 there, but I don't deal with it. I just put the negative out front, and then I don't have to deal with negative numbers. So I have 2 and 12, 2 and 6, and 2 and 3. So there's my prime factorization of 24. Again, because everything on my ends doesn't break down anymore. Now I look at the index. So over here, when I was doing square root, I put them into groups of 2. Over here, because it's cubed root, I want to put into groups of 3. So I'm looking for groups of 3. So I have one group of 3, one group of 3, group of 2, if that makes sense. I have a 2 coming out. So 1, 2 is coming out because it's all grouped up, and then I have 1, 3 left over. So I have -2 cubed root of 3. Okay, my last two examples are, I have multiple items inside the radical. So I'm going to apply the property. So this is where the steps from the beginning of the video come into play. I'm going to break it up, square root of 75, square root of x to the 8th, and square root of y to the 4th. Okay, so the square root of 75, I don't want the decimal version, so I'm going to do my factor tree. 75 gives me 3 and 25, and then 5 and 5. So square roots, I'm looking for pairs. So I've got 1, 5 coming out, 1, 3 left inside. So the square root of 75 is the same thing as 5 square root 3. The x to the 8th is the same idea. So by definition, x to the 8th is 8 x's written out. So I'm going to have x times x times x times x times x times x. Now square root, I'm putting them into pairs. I've got 1, 2, 3, 4. So everything is paired up, and I'm going to have 4 x's come out because only 1 comes from each group. And I don't have a radical left because everything had a pair. There was nothing unpaired to leave inside the radical. Same thing with the y's. I have 4 y's because it says y to the 4th. So pair, 2 pairs, which is going to give me 1y, 1y. So I'll have y squared. So now this is where step 3 comes into play, where I may want to rewrite it. I want to put everything that came out of the radical all the way up front, and then I'm going to leave that square root of 3 out back. So it was just a little rearranging. So that would be your final answer. All right, the last one, I got a whole bunch of stuff. First thing I need to do is apply the properties and break up every single number to its own radical. So in this case, I'm actually using both properties. I'm using the multiplication on top and the division. So the square root of 3. 3 is already prime. If I did a factor tree of 3, it wouldn't be able to break down any. So that one's going to stay the same. Now 11, x to the 11 means I'm writing out 11 x's. So 11 x's, I'm still in square root, so I'm going to pair them up. So I have 1, 2, 3, 4, 5 x's coming out, and 1 x left inside. Now on the bottom, the square root of 64, if I did that factor tree, everything would pair up. So 64 is going to give me 8 and 8, 4 and 2, 2 and 2, 4 and 2, 2 and 2. So I'm looking for pairs, which means I'm going to have 3 2's come out. So that'd be 2 times 2 times 2, which is where that 8 comes from. And again, because everything got paired up, the square root goes away completely. With the y to the 4th is y times y times y times y. So put them into pairs. I have 2 y's coming out, nothing left over, so the radical goes away. Now the only thing I'm going to want to do is just do a little rewriting. So I want to, on top, move everything that doesn't have a radical up front. So in this case, it's only x to the 5th. Now that x cubed, or that square root of 3 and the square root of x, I can move those to the back and stick them under one radical. So the square root of 3x over and that 8y squared. So that will be your final answer.